Alright, so the square root of 2 is rational. If a number is not rational, we categorize it as irrational. Definition: any number that cannot be expressed as the ratio of two integers is regarded an irrational number. Theorem: the square root of 2 is irrational. Proof 1. Inversely, suppose the square root of 2 is rational, which would imply that it may be expressed as the ratio of two integers p and q as follows. So the first step we can take here is to square both sides of the equation, and then we would disjoin the fraction by multiplying both sides by q squared, just like this. Next, I'm assuming this lemma, and it's a well-founded assumption, that the fundamental theorem of arithmetic states that every natural number has a unique prime factorization. This follows from the definition of prime numbers, which are natural numbers whose divisors are 1 and that number, and it assumes the existence of natural numbers as a set. Well, per this lemma, p and q up to the order of their factors, meaning up to but not including the order of their factors, each has a unique prime factorization, which is to say we can express p squared as the product of two factors, each composed of n prime numbers. Well, it follows that p squared has an even number of prime factors, and so does q squared, regardless of the number of factors composing either integer. While the expression on the right side of the equation above, namely 2 times q squared, would have an odd number of factors in its respective prime factorization. Notice that we already have one prime number, namely 2, in that expression. Therefore, the assumption that the square root of 2 is rational must be rejected. Proof 2. So the premise p squared equals 2q squared, derived above, implies that p is even. We know that if the square of a number is even, then that number is even. In the particular case, when p and q are mutually prime, q is necessarily odd, as we've just established p to be even. Moreover, the square of an even number is divisible by 4, not least of all because 2 squared, which equals 4, is divisible by 4. But clearly, 4 does not divide quantity 2 times q squared, where q is an odd number, which would imply that q must be even. And this forces a contradiction of the preceding condition that q is necessarily odd. As a result of this condition regarding the nature of q, we conclude that the square root of 2 may not be written as the ratio of two integers. And we're done.